Hello everyone. In this video I'm going to be looking at how to find the polar form of the complex number 3 plus 8i. For a problem like this, I'm going to convert a complex number into polar form. First of all, I'll understand that my complex number has the form z for any complex number a plus bi. In this case my a is 3, my b is 8. I'm going to put this in polar form. I'm going to use the same conversions that I would use for polar form to rectangular form, or for a polar point to a rectangular point. Normally, those are x equals r cosine of theta, y equals r sine of theta, and tangent of theta equals y over x. With my complex plane, a corresponds to an x, the x-axis, b corresponds to the y-axis, so I interpret them the same way. In other words, I would change these, and instead of x equals r cosine of theta, I'm going to have a. Let's try that again. A equals r cosine of theta, b equals r sine of theta, and likewise, tangent is now b over a. Using these, I need to figure out what is my theta, what is my r. To find theta, I'll use tangent, so here I'll say tangent of theta equals b over a, or 8 over 3 in this case. Now since tangent is positive, that means I'm in quadrants. Let me give myself some more space. That means I'm in quadrants 1 or 3 so far. I need to narrow it down further. Well, if I'm going to find theta, what I'll have to do is take the inverse tangent of 8 over 3 to find theta. Now recall that for inverse tangent, it's defined on the interval from negative pi over 2 to pi over 2. This corresponds to quadrants 1 and quadrants 4, as pi over 2 is up here, negative pi over 2 is down here. Since I have an overlap in quadrant 1, this tells us that we're in quadrant 1. All this does is confirm where we are in our quadrants. So when I take the inverse tangent, now with 8/3, that doesn't fall under one of our two triangles, our 30, 60, 90, or our 45, 45, right? So I would use a calculator here, and a calculator, making sure if I'm in degree mode, would give me 69.4 degrees, rounded. So now I have my value for theta. Next I need r. R is defined as our modulus of our complex number. Our modulus is the distance from the pole, or the origin of a graph, of a complex graph, to the complex point itself. It's the distance, and it works very much the exact same way as Pythagorean theorem. Our modulus formula is the square root of a squared plus b squared. In this case I know my a and my b, so it becomes the square root of 3 squared plus 8 squared, so 9 plus 64, 473. Now I would normally try to simplify this, but there's no perfect square that divides into 73. So my r is simply square root of 73. Move back, give myself a little more room. So now that I have that, I have my theta, I have my r. The form that I use for any complex number in its polar form is r times cosine of theta plus I sine of theta. Putting in my proper values, I have for my answer square root of 73 times cosine of 69.4 plus I sine of the same 69.4. Now I could go further and find a more specific decimal value for this, but in polar form this is as much as I want. This is a proper answer, a better answer, a more exact answer, to be specific. So again, to find my polar form, what I need to do is find the theta, find r, use my conversions, and then put it into its proper form.